Another ambiguous case here. Notice again that I have a side, and an angle are my knowns. I drew a sketch of this. Is this what the sketch looks like? Well, it does, because I already know what's going to happen here. So you may not be able to draw the sketch at the very beginning, but I'm using this as an example to show you how other ambiguous cases can result. I know my ratios of A and B is given, so let's look at the law of sines from the ratio of the A's. Sine of B is unknown, so let's solve that for the sine of B. B is 71, sine is 75, all over A, which is 51. Use a black box. Sine of B equals 71 times sine of 75 divided by 51. Sine of B equals roughly 1.34. And if I were to take the inverse of that, you notice that I can't have an angle that's greater than 1, or a result or a value greater than 1. And so because of that, I know that there is no angle that makes this true. So there's no way then to complete this triangle. There's no measurement of angle of B that I can get to complete this triangle or solve this triangle. So in this particular ambiguous case, the result does not form a triangle at all. And the reason why is I discover right here, I get to some value that I can't compute because it's outside of my domain range, or it's outside my domain. All right, so that was, and I got one more example of another ambiguous case. And for another example of an ambiguous case where I have a side, and an angle, does this ambiguous case form two triangles? And by example, I want to show you how does that look like and how do we know that this particular one does show two triangles. Well, the reason why it's possibility is because we know this value of A on this right side. Well, since it's less than B but greater than the altitude, it could swing all the way over, and then as it comes up, it'll connect again and form that second triangle. Or one triangle is this little sliver right here, and the other triangle is the entire triangle where this line stays over there. So how do we work this through, and how does this start to make sense given the law of sines that we know? Well, we already have the ratios of the A, so we can look at the sine of A, or sorry, A over the sine of A equals B is the other one I know, so B over the sine of B. Solving for the sine of B, all right, let's look at the black box here and see what black box tells us. (62) times the sine of 40 divided by 54 produces a sine less than 1 or greater than -1, so it means that it's defined 0.738. Since it's positive, we know that it produces two values. There's two possible values for where that's true. So let's take the inverse of sine. And so 47.5, 47.6. So B can equal 47.6, or B can also equal the sign that shows up in the second quadrant, which is 180 minus the 47.6, which equals 132.4. So those are two possible values that I have available to me, and are both these valuables values possible? Well, if I had one that was 40, and this one is acute, which is 47.6. Okay, that one's possible because then all those are less than 180 degrees. So that one can equal 40 plus 47, that's 87.6. So that makes that 92.4 degrees. That's a possible triangle. This one, I have 40 right here. And I know that this angle, we came up with 132.4. That's possible because both of those together are less than 180 degrees, which tells me there's enough room up there to have that. So that's 172.4, makes us 7.6. So all of those triangles are possible. So therefore, I have two triangles that could be part of this ambiguous case. And then from there, it's a matter of using the remaining law of sines to solve for the opposite sides. I already know this one's 62. So I can solve for C down here. A is 54. I already know that. This I know is 62, and that's also 54. And this is C. Oh, that's not much work left to do, so I might just do it for fun. The value of C here, I know what my A's were. Solving for C. Sine of A, sine is 40 degrees. Oh, sorry, sine of C. I got lost on that. But that's what you get for having sloppy handwriting right there. So that's sine of C times A. So let's do that one all over again. Sine of C, 7.6, times A, 54, all over to sine of A, which is 40. All right. Equals 11.1. So C in this skinnier triangle would equal 11.1. That seems, or not degrees, units, where they are. So that seems reasonable because that extends from the smallest angle. So that triangle is solved. And if I want to solve this other one, likewise, that's C equals the sine of C times A all over the sine of A. Sine of C is 92.4, so the sine of 92.4 times A, which is 54, divided by the sine of A, which is 40. And then sine 92.4 times 54 divided by sine of 40 equals 83.9. And that's reasonable because that's that's the largest angle. That's the line that extends from the largest angle. So what we saw here is that the information given on this side-side angle produced two triangles. And so for both of those, we saw both of those two triangles based on that original information.